All right, before we get rolling, let's make sure we got our calculators on degrees. So just test yours out here. We'll do a couple of these. Type in the sine of 30 on your calculator. For some of you, you're going to hit the sine button first, then the 30. For some of you, you have to do it the opposite direction. You got to hit the 30 first, and then put the sine button in. You should get 0.5 when you do that. And just for something different, let's do the tangent of 20. Tangent of 20, I'm losing my pen here. Tangent of 20 is about 0.3697, and there's some other numbers behind it. Now, it's very important that you get those numbers. If you're not getting those numbers, then we need to change the mode on your calculator. Anybody need their mode changed on the calculator? Okay. Then we should be ready to roll. Today we're going to get into what we call our trigonometric ratios. A lot of times they're called trig functions. That's really just a big name for the sine, cosine, and tangent. Those are the three we'll do this year. Next year, when you go to Algebra 2, you'll expand on it. But for this year, we're going to keep it pretty simple. Now, if you remember the word ratio, ratio can either be written as a fraction or you can have a colon in between the two numbers. We're going to write it as a fraction today. So we've got our three trig functions, sine, the cosine, and the tangent. I'm going to start with sine. Sine is spelled S-I-N-E. The abbreviation for it is S-I-N. Now, when you see that S-I-N, you read that as sine. Don't read it as sin. If you want to get made fun of in college, announce it as sin. People will laugh at you. It's not that it happened to me. So sine is going to be a ratio. We're going to write it as a fraction. And here's how it's going to work. We're going to take the opposite side. I'll show you what the opposite side looks like here in just a second. And we're going to put that over the hypotenuse. Now, to give you a little visual of what that means, let's say we have triangle ABC. And the trig functions we're going to use this year are always going to be on a right triangle. Next year, you'll expand that to non-right triangles. But for this year, it's just going to be right triangles. And then when we do sine, cosine, or tangent, we're going to do it for the non-right angles. So in this triangle here, that would be angles A or C. And let's say that the sides have, let's keep it simple. We'll call these sides 1, 2, and 3. And then if I use my abbreviation for sine, let's say I want to find the sine of angle A. To find the sine of angle A, I'm going to use my abbreviation for sine with a capital A behind it. Find the sine of angle A, I'm going to get a ratio. That ratio is the opposite side over the hypotenuse. Now, for the sine of angle A, I'm going to go up here to angle A. And when I look at my triangle, on the triangle, the side that's labeled 1 would be adjacent. That's right next to angle A. The side across from it, the 2, would be opposite angle A. And then 3 we know is the hypotenuse. That's going to be your the side across from the right angle. That's always the hypotenuse. So if I go opposite over hypotenuse from angle A, the side opposite angle A is a 2, and the hypotenuse is the 3. So that's the first thing we'll do with it. Now we can also do that sine for angle C. If I want to find the sine of angle C, abbreviation for sine is SIN. That capital C behind it means I want the sine of angle C. And if I pick angle C, if I go from angle C, things are going to be just a little bit different. Sine, you want opposite over hypotenuse. The side opposite angle C is the 1. And your hypotenuse here is still 3. The sine of that one would be 1/3. So that's a little sneak peek into what we're going to get going with this. All right, there is your ratio for the sine. Cosine is the second one we're going to do. Cosine is abbreviated COS. Now again, when you see that abbreviation there, COS, you read that as cosine. Don't call it cos, that's cosine. And then we're going to get a ratio, a fraction for the cosine also. Ratio for the cosine is pretty similar. Instead of the opposite side, we're going to take the adjacent side this time. And we'll put that over the hypotenuse. I'm not going to draw another picture for cosine. We'll get into some examples of that here in just a second. Then our last one is the tangent. Tangent is abbreviated TAN. Same thing with this. When you see the abbreviation TAN, you read that as tangent, not tan. It's tangent. And then to find the tangent, we're going to put the opposite side over the adjacent side. So what the next couple sections come down to are just remembering those ratios right there. Sine, cosine, and tangent. And then you got to remember how you're going to set up your fraction. Now to do this, we have an age-old acronym we use. It is SOH CAH TOA. That little acronym there, SOH stands for sine equals opposite over hypotenuse. That's the ratio we get for sine. CAH stands for cosine is equal to the adjacent over the hypotenuse. TOA stands for tangent is opposite over adjacent. So you're pretty brand new to this. Today we'll write this down several times, and as you get more familiar with doing SOH CAH TOA, this is something that you'll just you'll be able to remember this pretty easily. By the time we get to our test over this, you'll remember SOH CAH TOA. All right, now let's show you some examples. There's 2 things we're going to do with this today. And today we're basically going to cover half of section 4. We're going to do the other half on Thursday or Friday, whenever you come in next. First thing they're going to have us do is express each ratio as a fraction and a decimal. But we're going to start with a picture. We're going to have a right triangle. And that right triangle is going to be triangle QRP. And then like we did on our picture up here, we're going to give those sides some lengths. QR is going to be 15. RP is going to be 8. QP is going to be 17. And then before we show you the problems, I'm going to write SOH CAH TOA down once again, because we're going to use this with every single one of the problems we do today. All right, let's work our way through this here. We'll call this first one letter A. They're going to start with the sine of angle P. And again, they want this as a ratio, this ratio as a fraction and as a decimal. So I'm going to start with a fraction. Sine, if you remember SOH CAH TOA, your abbreviation for sine is going to be opposite over hypotenuse. So they want angle P. If I go down here to angle P, I'm going to put opposite over hypotenuse. From angle P, if I go across, the opposite side is 15. And then on the bottom goes the hypotenuse. Across from the right angle is 17. There would be your ratio as a fraction. Then they also want it as a decimal. So on your calculator, you got to put 15 divided by 17. And when we get to the test over this, we're going to round to the nearest tenth. So I've got 0.88. If I round that to the nearest tenth, that's going to be 0.9. There's the two answers we're looking for. Let's bounce around a little bit. Let's go tangent of angle P. To set up your fraction for tangent, you want to remember your SOH CAH TOA. TOA, tangent, stands for opposite over adjacent. We're going from angle P. So I come down here to angle P. I want opposite over adjacent. The opposite side from angle P is 15. And the adjacent side is going to be next to it. From angle P, I have two sides next to it, 8 and 17. Which one's going to be the adjacent? The 8 is adjacent. Why isn't the 17? That's your hypotenuse. 17 is across from the right angle. So if you're stuck determining which one's the adjacent one, it's going to be the one that's not the hypotenuse. So there's your ratio as a fraction, and then if you take 15 divided by 8, that's 1.875. We'll round to the nearest tenth, which would be about 1.9. Let's try one more together. Let's go to the cosine of angle Q. We're going to mix it up a little bit this time. Instead of going from angle P, we're going to go from angle Q this time. And same deal, we're going to get a fraction and a decimal. For cosine, if you go back to SOH CAH TOA, cosine is adjacent over hypotenuse. So we're going to go to angle Q. Here's angle Q at the top. We want the adjacent side over the hypotenuse. From angle Q, the adjacent side would be 15. Now again, that's one of those where you have two sides right next to angle Q. The adjacent one is 15 because 17 is across from the right angle. That's going to make 17 your hypotenuse. That hypotenuse we want on the bottom. And then we've already done 15 over 17 on our calculator. You're going to get 0.9. Anybody need to see another one of those? They won't have you do from R, and here's why. If R is a 90-degree angle, if you put in your calculator, you can see this on the screen up there. Getting a little bit of a glare. If I put in the tangent of 90, we're going to get an error. Because of that, we don't use the right angle when we do these. We will always use the non-right angles. So they'll never ask you to find the tangent of a right angle because of that error that you get on your calculator. So anytime they're asking for sine, cosine, or tangent, you're going to be going from the non-right angles to get those. Any other questions on that? All right, let's give you a couple to try all by yourself. And we'll mix it up. We'll go with the tangent of angle Q. We'll want a fraction and a decimal for that. And let's see, let's do the cosine of angle P. See if you can get those two all by yourself. One more time to finish this. All right, let's check them out here. Tangent of angle Q. You go back to SOH CAH TOA. Tangent is going to be opposite over adjacent. We want to go from angle Q. Here's angle Q. The opposite side would be 8. The adjacent side would be 15. And again, I picked 15 as the adjacent side because your 17 is the hypotenuse. That's across from the right angle. So 15 is your adjacent side. 8 divided by 15, have we done that yet? No.
It's 0.23.
What is it?
0.05.
Point what?
0.5. You can just start. That's just 0.53.
Yep, and you round it off. We'll go to nearest 10, so 0.5. Cosine of angle P. To get cosine, we're going to put adjacent over hypotenuse. And from angle P, here's angle P down here. The adjacent side would be 8. It's not going to be 17 because 17 is across from the right angle. That's the hypotenuse. And when you do cosine, you want the hypotenuse on the bottom. That's going to be 17. 8 over 17, we didn't do that yet either. 0.5 again. All right. Any questions on how I got those two? Okay, this is the first thing they're going to have you do with it. Just identify what the sine, cosine, and tangent are. Now, the reason we use sine, cosine, and tangent is so we can find missing parts on a right triangle. That's where we're going to go next. So with these, let's see. Directions are just going to tell us to find x. I forgot what letter I'm on. This is letter D. Hi, Mr. Saget.
What's up?
How you doing?
Good. Is Angel here by chance?
Yes. Angel.
Angel?
You need her?
I do, because she needs to finish up her test. And
Okay.
of course, they have to finish it today.
Yep. Angel.
Just grab your stuff. Thanks, man.
Yep. All right, once again, we're going to start with a right triangle. And they're going to draw these right triangles all kinds of different ways. And then what they're going to do is they're going to give you at least one of the non-right triangles. Usually they just give you one, but sometimes they give you both. On this one, they're going to give us a 25-degree angle down on the bottom left. And then they're going to give you two other parts. We're going to have 18 here, we're going to have X here. And what I'm going to do next is kind of going to remind you of when we did 30, 60, 90 triangles. What I'm going to do is identify the parts they give us. When you do sine, cosine, or tangent, you're going to use one of the non-right angles. In this case, the only one we have is the 25. So I'm going to use this 25-degree angle, and I'm going to look at the two sides they give me. If I go across from this 25, I get the X. So this is the side that's opposite the 25. And the 18 would be adjacent to it. So once again, you go back to the angle they give you, the non-right angle they give you, and you identify your two parts. X is the opposite side, 18 is the adjacent side. The side we didn't identify here is the one they don't give us. That would be your hypotenuse across from the right angle. Now I've got an adjacent and a hypotenuse, so I'm going to go back to SOH CAH TOA. And what I'm going to do with SOH CAH TOA is identify which one uses adjacent and opposite. Looking at SOH CAH TOA, which one uses adjacent and opposite? Yep.
Tangent. No.
Tangent's opposite over adjacent. Not quite tangent. We want adjacent. Oh, you're right. Geez. Adjacent and opposite. Yes. I'm still asleep today. Adjacent and opposite. Tangent uses adjacent and opposite. So that tells me we're going to use tangent when I'm using this triangle here. So my abbreviation for tangent is TAN. And then right behind your abbreviation is always going to be the angle. The angle we're using is the 25. And to find the tangent of 25, we'll go back to that ratio we just talked about. Tangent is opposite over adjacent. Our opposite side is X. Our adjacent side is 18. And we're going to solve for X. Now, when you get to this point, you want to get the X all by itself. I have X divided by 18 on the right. If I wanted to get the X all by itself, what would I do to both sides? Multiply by what?
18.
18. But you have to do it to both sides when you do that. Those 18s will reduce down to 1, leaving you X on the right. And then this we're going to put into our calculator. Now, again, it depends on what kind of graphing or what kind of scientific calculator you have as to how you put this in there. If you got the blue one like I have, you can put it in just like it looks here. 18, then you hit the tangent button, 25 behind it. That's 8.3935. Again, we'll round to the nearest tenth because that's what we'll have you do on the test. If I round that to the nearest tenth, that's about 8.4. That side over there would be about 8.4. Now, if you did not get 8.4 on your calculator, what you might have to do is put the 25 in first, then hit the tangent button, and then the number that comes up there, you multiply by 18 to get to your 8.4. Let's check the calculators. Is there anybody who's not getting to 8.4? Everybody's good with that? Okay. Let's try another one. Let's see. Let's go with this right triangle. This time our X is over here. Got a 5 and a 7-degree angle here. Now again, when you're first new to doing this, you might want to mark your sides. They're giving us a 7-degree angle. That's the non-right angle that they're giving us. So we're going to start from that 7-degree angle. If you look at the 5, would the 5 be adjacent, opposite, or hypotenuse? That's your hypotenuse. That's across from the right angle. And if you go across from the 7, you have the X. Would that be adjacent or opposite?
Opposite.
That's opposite. The side we didn't mark would be the one right next to it. That's the adjacent side. Okay, now we're going to go back to SOH CAH TOA. In our picture, we identified the hypotenuse and the opposite. Which one of our trig functions uses hypotenuse and opposite? Craig or Jackson?
Sine.
Sine does. Sine is opposite over hypotenuse. Now I can use this to set up my equation. Sine is abbreviated SIN. Behind the sign, behind the abbreviation, always goes the angle, which is 7. Then we'll put our equal sign and set up our fraction. Sine is going to be opposite over hypotenuse. Opposite side is x. Hypotenuse is 5. Let's stop right there. Are there any questions on how I got to this equation? Okay, let's take it from there. We want to get the x all by itself. What would you do to both sides? Multiply by 5. Those reduce down to 1, leaving you x. This we can put in our calculator. Once again, it depends on what kind of calculator you have. Some of you can put it in just like it looks. Some of you will have to do the sine of 7 first, then multiply by 5. When I put it in my calculator, I get about 0.6093. So we'll round that to about 0.6. How many think they're getting hanged? Okay, picking up on that pretty good. Let's try another one. Let's go with this right triangle. We're going to put a 70-degree angle up on top, and an x and a 15. And again, I'm going to start by identifying the parts. We've got our 70-degree angle. That's the non-right angle they're giving us is 70 degrees. The 15 right next to it, is that going to be hypotenuse, adjacent, or opposite?
Adjacent.
That's adjacent. That's right next to it. And it's not the hypotenuse, so that's your adjacent side. How about the x? What's the x going to be?
Hypotenuse.
That is your hypotenuse. And now we go back to SOH CAH TOA. SOH CAH TOA is going to tell us which one of our trig functions to use. On this one, we have the adjacent side and the hypotenuse. So I'm
Cosine.
looking at my options here. Adjacent and hypotenuse goes with the cosine. And now we can put together our equation. Cosine is abbreviated COS. What always goes right behind the cosine? The angle. We're using a 70-degree angle. And then our fraction is going to be the adjacent over the hypotenuse. The adjacent side is 15. The hypotenuse is x. What's different about this one?
The x is on dominant.
X is on the bottom. Now, we're going to do something a little bit different when x is on the bottom. There's two different ways you can do this. And over the years, the easiest way we've found is to write this cosine of 70 over 1. Because you can put anything as a fraction over 1. When I do that, I end up with a proportion. Go back to earlier this year, how do you solve proportions? Cross multiply. We're going to have cosine of 70 times x. We're going to write that as x times the cosine of 70. The reason we put the x out front is we want to know the variable is out all by itself here. If you write it as cosine of 70x, people might think the angle measurement is 70x. So we're going to put the x out front. Then we cross multiply here. 15 times 1 is 15. Now we got to get the x all by itself. To get the x all by itself, we're going to divide this one. And the cosine of 70, don't do this, just follow along with me. If I put the cosine of 70 into my calculator, I get a number. This whole thing, cosine of 70, is you should think of as one thing. It's going to be a number. So when I have this x here, and I want to get rid of that cosine of 70, to do it, I'm going to divide both sides by the cosine of 70. Because those cosine of 70 reduce down to 1, leaving me with x. Now again, this part here is going to depend on what kind of calculator you have. If you have a blue one like I do, you can put it in just like it looks. 15 divided by cosine of 70. When I do that, I get 43.857. So we'll round that to 43.9. Now, if that doesn't work on your calculator, what you might have to do is type in the 15 first, do the division bar, and then hit your 70 cosine, and then the final thing you have to do is hit the equal sign. And that should get you to 43.9. Once again, it just kind of depends on what kind of calculator you have. Is there anybody's calculator not getting them to 43.9? Do you have one of the blue ones? Yep, so you should be able to put in 15 divided by cosine of 70. Right? Yep, there you go. Anybody else not getting there? Okay. Let's do at least one more. Oh, let's see. Let's try this one, letter G. There's our right triangle. 61-degree angle here. Two sides they give us are X and 24. And we'll start again by identifying the parts. 61 is the non-right angle they're giving us. The X is across from the right angle, that's the hypotenuse. And the 24 is across from the 61, that's going to be the opposite side. The side we're not using this time around is the adjacent side, the one right next to the 61. Once we get to here, now we go back to SOH. We have hypotenuse and opposite being used here. Which one of our trig functions uses the opposite and the hypotenuse? Sine does. Sine is opposite over hypotenuse. So that's going to help us set up our equation. Sine, abbreviated SIN. Behind the sine always goes the angle. The angle is 61 degrees. Then for your fraction on the right, we're going to put opposite over hypotenuse. Opposite side is 24. Hypotenuse is X. This is another one where you get the X on the bottom. When that X shows up on the bottom, you can just write this as a proportion. Put that over 1. Then we can cross multiply. We have X times the sine of 61 on the left. We have 24 times 1, which is 24. I want to get this X all by itself. To get the X all alone, what would I divide by?
Divided by sin 60.
Sine of 61. Those are going to reduce down to 1, leaving you X. Now again, try this on your calculator to make sure you know how your calculator works. We want 24 divided by the sine of 61. My calculator, that gets us to about 27.4. Anybody's calculator not getting them to 27.4? Okay, how many think they're getting the hang of it now? All right, how many need to see another one? We're good to go. All right, let's have you try a couple all by yourself. Since this is brand new, let's make sure you got it. Let's do. This one's going to be a 40-degree angle up here. And then our second one will be let's see here. Let's do 27-degree angle on that one. All right, using SOH CAH TOA, see if you can come up with both of those two. And just like on the test, go ahead and round to the nearest tenth. That's how we'll have you do it on the test. These look pretty good for our first day. Anybody need more time to finish it off? Give me another minute here. All right, let's test them out, see where we're at here. First one, from our 40-degree angle, that's the non-right angle they're giving us. The 6 is across from it, that would be the opposite side. The X is right next to it, that would be the adjacent side. And then the side we're not using is the hypotenuse, that's across from the right angle. So we've got adjacent and opposite on this one. And then if you go back to SOH CAH TOA, you want to figure out which one uses adjacent and opposite. TOA. O and A stand for opposite and adjacent. That's going to be the tangent. So on this one, we're going to use tangent. Behind the tangent goes the angle, which is 40. And then for your fraction on tangent, we want opposite over adjacent. Opposite side is 6. Adjacent side is X. Now, as I was walking around looking at those, some of you will do this every single time. And if you want to do this every time, you can. You can make this into a proportion anytime you want by putting this over 1. You can do it on this type of problem, or you can do it on this type of problem. So if it helps, go ahead and do that as a go ahead and do it as a proportion. Once you're to here, you just cross multiply. That gives you x times the tangent of 40. 1 times 6 is 6. To get the x all by itself, we divide by the tangent of 40. Those reduce down to 1, leaving you x. And then on your calculator, we want 6 divided by tangent of 40. About 7.15, so we'll round that to about 7.2. Any questions on how I got to 7.2? Okay, let's try the other one. This one, you got a 27-degree angle. The 19 is across from the right angle, that's the hypotenuse. And the x is right next to the 27, that's the adjacent side. Go back to SOH CAH TOA. We want adjacent and hypotenuse. Adjacent and hypotenuse are used on the cosine. So here's our equation. Cosine, we abbreviate COS. 27 is the angle that goes behind the cosine. Your fraction for cosine is adjacent over hypotenuse. Adjacent side is x. Hypotenuse is 19. Now again, you can solve this by multiplying both sides by 19, or if you're more familiar with the proportions and you want to put that over 1, you can do it this way. Cross multiplying it would give me 19 times the cosine of 27 here. 1 times x is x. If I put that in the calculator, 19 times cosine of 27, about 16.92. We'll round that to 16.9. Any questions on how I got here? How many had both of these right? Okay, that looks very good. All right, does anybody need to see more? Raise your hand if you want to see another. Good with those, okay. Now, today, we've only gone halfway through the section 6 or section 8.4. So if you want to, you can start the homework because there's part of this homework assignment you can do. If you want to wait to do this on Thursday or Friday, you can do that also. But here's the first part of the assignment that you can do if you choose to today. It's on page 573. These problems here. You want to wait to do that on Thursday or Friday, that's fine also after we show you the second part of this section. I'll leave that up to you. Some of you, while you got this fresh in your head, you may want to start it right away. So when you come in on Thursday, we'll review this a little bit, maybe do 1 or 2 more of these, and then we'll go into the new part of section 4. That will be on Thursday. You're on camera.